Chapter 9, Applications of Vectors Operations. This is Chapter 9, Applications of Vectors of Operations. Okay. So here we are going to use the properties of vectors in order to have or to prove some geometric ideas like collinear points, parallel lines, use of midpoint, center of gravity of a triangle. To start with the first one, and by the way, you already have it in the summary I sent about vectors. More properties, here you have it. Collinear points, two lines are parallel, the midpoint, and centroid of a triangle. Now, to start with the first one, we said that from the previous lesson, two vectors have same direction if two vectors u and v have same direction. If and only if what? What property we stated about two vectors having same direction?
نعم أستاذ كان صوتك عم بقطش.
If U equal KV, where K is constant.
Right. I was saying, Ribal, what property we stated about two vectors having same direction? Same direction, let's say here we have vector u.
okay.
This is vector u, and this is another vector v. These two vectors have same direction. It means that one of them is equal to constant times the second. It means that one of them is equal to constant times the second. Same sense or opposite sense, but they have the same direction. Okay, right. So in this case, we said u is equal to some constant times v. Good. Same direction, it means u is equal to some constant times v. Right. So to consider the case where we have, let's say, if vector AB is equal to some constant times vector AC, what can we say then about the points A, B, and C?
They are collinear.
They should be collinear. Because if, for example, you have point A, B, and here is point C, can we say that vector AB and vector BC have the same direction? In this drawing, AB and BC, do they have the same direction if they are not collinear?
No.
No, because they don't have the same direction. The points are not, or line AB and line BC are not parallel. So AB can't be equal to some constant times AC in this case. So if we have AB is equal to some constant times AC, then we must have A, B, and C are collinear. These 3 points should be collinear. Okay, so here in case AB is equal to some constant times AC, then A, B, and C are collinear. So here another way to prove that 3 points are collinear, in addition to what you studied in grades 7, 8, and 9. In order to prove 3 points are collinear, sometimes you said that the angle is 180, or for a certain reason the point belongs to a certain line. And the height, for example, orthocenter, and then should belong to the height. She's certain given. Here we have another way to prove 3 points are collinear. If you prove that vector AB is equal to some constant times vector AC. or not necessarily AA. For example, AB is equal to some constant times vector BC. Or here you have BC is equal to some constant times vector AC. And it means that we must have some point in common or one point in common. So here AB is equal to some constant AC. It means that the 3 points should be collinear. Okay. For the parallel lines, if we have, for example, still on the same idea here, same direction, it means lines are parallel. Now, if, for example, you prove that AB is equal to some constant K times CD, then what can we say about the lines if the points are not collinear? Assume that A, B, C, and D are not collinear. If they are not collinear, then we may have collinear points. Example. Okay. Then, if assuming that the points are not collinear, what can we say about lines AB and CD?
They are parallel.
They should be parallel. These lines should be parallel graphically. If they are not parallel, let's say here we have AB and CD. These lines are not parallel. These two lines, AB and CD, are not parallel. Can we have AB is equal to some constant CD? If they are not parallel, then vectors AB and CD will not have same direction. شيك نحن حكينا بالprevious lesson. In vector AB and vector CD have same direction, it means that the lines should be parallel. Line AB should be parallel to line CD. Right? Line AB should be parallel to line CD. Right? If they are not parallel, they don't have same direction, then this statement will not be true. Hey, now it's all true. For that reason, the lines should be parallel. To say that AB is parallel or AB is equal to some constant times CD, the lines should be parallel. Right? So here another way also to prove that lines are parallel, if you prove that vector is equal to some constant times another vector, or two vectors, one of the vectors is on the first line, the second vector is on the second line, and prove that one of the vectors is equal to some constant times the second. يعني بمعنى ثاني, let's say you have here line D, this is line D, and here you have line D prime. Okay, and the question proved that these two lines are parallel. Enough to have 2 points A, B on the first line and 2 points CD on the second line, and prove that vector AB is equal to some number K times vector CD. This number, positive number, negative number, ما بيهمني. إنه some constant times vector CD. Okay. In this case, this is equivalent to say that line D is parallel to line D prime. Is that clear? Collinear parallel points or collinear points and parallel lines? Any questions?
No.
Okay.
لا
I was saying here that the points are not collinear because we may have the case where the 4 points are collinear and we will have this property. Yani, if AB is equal to some constant times CD, then we will have one of two things. Either the lines are C and here is D. Well, still AB is equal to some constant times C. Okay. بس نحن عم نقول انه if the points are not collinear, what can you say about the lines? The lines will be parallel. This is the second property, or the property I mentioned here. If two lines D and D prime are parallel, equivalent to say that AB is equal to some constant CD, where A and B are 2 points on the first line, C and D are 2 points on the second line. Okay? واضح؟ مفهوم اللي عم نحكيه؟
ايه استاذ.
Good. Now, for the midpoint, if you have, let's say, بار ما فيش هنا هون بار. Can you draw bar? مش كأنه okay. For the midpoint, if you have, for example, OA plus OB, what does it equal? If you have OA plus OB, here you have OA and OB in general is equal to what?
OC, where C is the fourth vertex of the bar.
Very nice. It's equal to OC, where C is the fourth vertex of the parallelogram OA CB. So you're here, or C is the fourth vertex of the parallelogram OACB is a par. Good. Parallelogram. So just a moment. Okay. Parallelogram ABCD. What can you say about the diagonals of a parallelogram?
They bisect each other.
Bisect.
They bisect each other. So here, if you draw this vector OC and AB, and let's say that the point here is point I is the intersection of the two diagonals. So it is the midpoint of AB, and I is the midpoint of OC, right? Is that true? Diagonals bisect each other. Right. What can I say about vector OC and vector OI? How can you write OC in terms of OI? How can we write vector OC in terms of
OC
OI?
equal to OI.
It's 2 OI. OC, it's equal to OI. Why? Because I is the midpoint of OC. نرجع نرسمها هيك رسم بحالها. هيدي O, هيدي C, and here we have point I. First of all, the direction OC and OI, they have the same direction. OC and OI, they have the same sense from O to C, from O to I, and going from O to the right side. Okay. And for the magnitude, since I is the midpoint, then OC is equal 2 times OI. So as vectors, OC is equal to OI. Like, this means that OA plus OB is equal to 2 OI, where I, what is I? بلكي مش معودين عليها. I هي
هي
شو؟
الميد
midpoint لمين؟ midpoint of
AB.
of AB. OA plus OB is equal to 2 OI, where I is the midpoint of segment AB. And here, a remark that we are going to mention. O is any point. O, hayalla point. And here, if you, for example, you consider also point D here, okay? D, any
Hello.
point in the plane. Hello, D.
أستاذ سامع
إيه.
شريف.
نعم؟ إيه بديع؟ بديع. طلع بديع. Okay, as I was saying here, if D is any point, any other point in the plane, also dA plus dB will be equal to 2dI. طيب لاحظ شغلة هون حتى نفهمها صح ونعرف نطبقها صح. like بشو مبلشين نحن هون؟ O O O. And this point here, this point I, will be the midpoint of this segment, segment AB, segment AB. Okay? And this property is also true on the opposite side. I mean, if you prove that for a certain value, for a certain given, if and for a certain point, one point, O, so that OA is plus OB is equal to OI, then for sure I will be the midpoint of segment AB. If you prove that OA plus OB is equal to 2OI, then I will be the midpoint of segment AB. هذا اللي نحن كاتبينه هون. OA plus OB is equal to OI, where I is the midpoint of segment AB. Okay? Is that clear? Do you have any questions? Any questions?
No.
Right. The last thing, the center of gravity. Center of gravity or centroid of a triangle. Why did they multiply isosceles? طيب
أستاذ بديع الواي فاي عنده مش منيح.
بديع الواي فاي عنده مش منيح. طيب طيب assume that we have a triangle ABC, any triangle, and let's say G is the centroid. G is the centroid of triangle ABC. Do you know the meaning of centroid?
Yes.
What is the centroid?
Intersection of medians.
Intersection of medians. And what are the medians? What is a median?
Line to the midpoint of the facing side.
It is the line joining the vertex to the midpoint opposite this vertex. Yeah, for example here, let's say we have here I, this is the midpoint, and here J is the midpoint, and here K is the midpoint. Medians, we have, here is the first median, the second median, and this is the third median. And the point of intersection, G, is the centroid. Okay, خلينا نسميهم I, J, K. So centroid, it is the intersection of medians. I is the midpoint of segment AB. K is the midpoint of segment BC, and J is the midpoint of segment AC. We have properties in medians and of centroids. You already know, it from grade 8. What can I say about JK and JA? Compare, not as vectors, okay, magnitudes. What can I say about JK? and JA. Yes. Do you have any idea?
JA equal to GK.
صح. GA is equal to 2GK. Here we have GA is equal to GK. Without using vectors, I mean, sorry, magnitude, only magnitude. And what about the GA and GK? Sorry, لا and AK, sorry, on لحظة ضيعنا. بقصد AK هي ذاتها هكذا. AK and GK.
Equal 3 GK.
It's equal to 3 GK. طيب, what about AK and GA? It's
2 أستاذ 3 على 2.
3 over 2. Or you can say طبعا هذه equivalent to say the following, that GK, this one, the small one, is 1 over 2 GA, and GK, the small one, is 1 over 3 GA or AK. GK is 1 over 3 AK, and the last one, GA, the GA, it's 2 over 3 GA. Yeah? The reciprocals on كلهم بعض هو reciprocal. طيب, now for vectors. For the vectors, of course, here all these three vectors, GA, AK, and GK, GA, GK, and AK, all three vectors, they have the same direction. Okay. طيب, يعني هون بضل عندنا نفس الكونستانت, بس انه بشوف السنس اذا positive or negative. طيب, I'm going to find the sum of GA plus GB plus GC, GA plus GB plus GC. Let me find the sum of these three vectors, GA plus GB plus GC. Yep. If you consider these two, GB plus GC, don't try GA plus. What is the sum of GB plus GC?
Two GK.
Very nice. It's 2 GK. Why?
لأنه K هي midpoint of BC.
لك وينه؟ بعدنا هلا بنحكيها. OA plus OB, it's 2 OI, where I is the midpoint of AB. فإذا هون, like, we have the same initial point O and O. Here we have the same initial point G and G. Hey, we have GB, GC, the same initial point. So the answer will be 2G something. And what is this point? It should be the midpoint of BC. The midpoint of BC. So what is the midpoint of BC here? It is K. So the answer is 2GK. نرجع نعيد. According to this property we just studied. Okay. OA plus OB, it's equal to 2OI, where I is the midpoint of AB. Okay. How to memorize it or how to understand it? We have the same initial point OO and then O. And the second point here will be the midpoint of the terminal points AB, the segment, I mean, terminal points AB. Right. So here we have G, G, the same initial point. So the answer will be equal to G something. This something, we mean midpoint of this segment BC. Midpoint of segment BC, it is K. نرجع له GA plus 2GK. Didn't we say here that GK is equal to, or AG is 2GK? By vectors, using vectors, AG is 2GK. AG, I'm going to write here, but AG, it's equal to 2GK using vectors. As vectors here. ليه? Because in magnitude, AG is double GK. Look, hey, the segment is double this 2 times. For the direction and sense, of course, they have the same direction since they are collinear. And the sense from A to G, from G to K, they have the same sense. So here you can replace 2GK, you can replace 2GK by AG. So here it's equal to GA plus AG. Okay? And GA plus AG, what is the answer?
G.
So GA plus AG,
0.
0. It is GG, which is
ايه صح it's zero.
0 vector, which is equal to 0 vector. So here, in any triangle, G is the centroid of this triangle, then we will have GA plus GB plus GC equal to 0 vector. GA, okay. GA plus GB plus GC equal to 0 vector. And vice versa. The opposite. The opposite is also true. Yani, if you prove that, according to the given, I don't know. If you prove that GA plus GB plus GC equal to 0, then G will be the center of gravity of the triangle. This is this property. G is centroid. هلا بنحكي عن الثاني. في عندي هاي B. G is centroid of triangle ABC, then GA plus GB plus GC equal to 0 vector. And the opposite. If GA plus GB plus GC equal to 0, then what? Then G is centroid of the triangle. Okay? Yani, if the question, prove that G is centroid, you prove this. You prove GA plus GB plus GC equal to 0. Okay? If you are given that G is centroid of the triangle, then directly you can say GA plus GB plus GC equal to 0. Okay? Is that clear? Do you have any questions
Yes.
now?
لا أستاذ.
طيب. Assume that you have a point in the plane. Still, same given here. وين بنكتبهم لنا هوديهم. طبعا no need to write anything except this if you want to add it. هي مش كاتبها بالريماركس لانه it's property from grade 8. يمكن كان احسن لو زدتها بس ما انتبهت زيدها. فيكم تكتبون نوتس عندكم هو بس انه هو GA it's half or GA is double GK and so on. طيب بس الباقيين هودي كلها عم بحكيهم مكتوبين عندكم بالنوتس. طيب now if you have any point محل ما بدك outside the triangle, inside the triangle, or on a side of this triangle, يعني مثلا let's say here is M. Okay, محل ما بدك الpoint M. Okay, I'm going to find the sum of the vectors MA, MB, and MC. MA plus MB plus MC. Let's نشوف what will be the answer. Can we insert a point on these three vectors? Can't I insert point G? Here, insert point G. and here insert point G, and here also point G, right? I can write mg plus GA. So here for this vector, insert point G. Right. The same idea for the other vectors, insert also point G. Here point G and point G. So you get mg GI, mg plus GB. And the third one also G, mg mg plus GC. Right. So insert point G, point G, point G. Now we will have mg plus mg. What do you get?
3mg.
It's 3mg plus, for these three, GA, GB, GC, GA plus GB plus GC. What is the sum of GA
Zero.
plus GB plus GC?
It's 0.
It's 0. We just proved that GA plus GB plus GC equal to 0 because G is a centroid. So the answer will be 3mg plus 0, which is equal to 3mg. So here, if you have any point on the plane, any point M, MA plus MB plus MC is equal to 3mg, where G is the centroid of the triangle. MA plus MB plus MC, it is equal to 3mg, where G is the centroid of triangle ABC. G is the centroid of triangle ABC. And vice versa. If you prove that for a certain point, for a given point M in the plane, if you prove that MA plus MB plus MC equal 3mg, then G will be the centroid of the triangle ABC. like هون كيف كاتبينها او كيف مبلشين يعني like هون عندك M والانسر 3M. okay, وهي البوينت will be the centroid of A B C. مثل قصة الميد بوينت عندك هون O O O. اوكي، هاي البوينت الثانية وين رح تكون ميد بوينت اوف اي بي. اذا كانوا ثلاثة بتكون سنترويد لتريانجل اي بي سي. Is that clear? Do you have any questions? Any questions?
No, Ustaz.
Good. We still have, by the way, هيدا هو درسنا. We are going to move to the exercises. We still have less than 1 minute, so I'm going to end the meeting now and start a new meeting. We are going to solve exercise number 1, page 101.